Okay, class, today we're going to talk about comparing populations. Okay, so what I want you to do with your partner is on these vocabulary words here on range, minimum, maximum, outlier, interquartile range. You see, I have drawn box plots here. I want you to go through here and I want you to label, and your box plot does not have to look like mine. It doesn't have to look like mine, but I want you to represent each one of these on these box plots. So range, I would identify this, and I'm going to do this one with you, and I'm going to give you an opportunity to do the others by yourself. So range, I want you to go through here and do that, please. Now, for range, the range here is talking about the entire data set. And we know that the range is the maximum minus the minimum. Okay, so my range here would be from, we're talking about my whiskers here. So my range is talking about my whiskers. So it'll be from here to here. Okay, so that would be my range. So now you see how I want you to do that with your partner. So go through each one of these and identify now the maximum, the minimum, the outlier, interquartile range. Okay, so here's what you should have identified as the maximum, which is going to be that farmost whisker. Your minimum is going to be that first whisker there. Okay. Your outlier is going to be here because we see the data is skewed all the way here to the left. And this one's over here by itself where most of the data is to the right. So it's by itself. Interquartile range would be the box. Okay. All right. So let's go ahead and go on the inside here. All right. So we're going to use this description here to complete exercises 1 through 3. All right, so here's our scenario. Students in 2 science classes were asked to write a research paper. The students used the internet to find websites related to their research topics. We're going to answer the questions about the 2 classes' use of the internet based on the samples in the dot plots. Okay, so here are the dot plots here. All right, so I'm going to pause here and I want you to talk with your partner. Just look at them, look at class A, look at class B, and what do you notice about the 2? Okay, so now that you and your partner have discussed those 2 dot plots, let's look at number 1 here. It says, how do the ranges of visits compare? Okay, so we know that the range here is talking about the minimum and the maximum numbers. Now, what are we going to do with those 2 numbers? We're going to subtract them. Okay, so let's look at class A. So we're going to take this one step at a time. So class A's range. Okay, so my minimum number is 4 and my maximum number is 8. So my range there would be 8 minus 4. So the range would be 4. Okay, for class B, okay, the minimum is 2, the maximum is 5, so it'll be 5 minus 2, which would give me 3. Okay, so what does that say about my data? These are the ranges. Okay, class A, the ranges are from 8 to 4, and for class B, they're from 5 to 2. All right, now, second question asks me, how do the medians compare? How do the medians compare? So I'm going to pause here. I want you to take about 30 seconds, and I want you to talk with your partner and answer the question, how do the medians compare? Okay, so we know the median is the middle number. So for class A, if we cross out one number at a time, my median would be 7. Okay, so for class A, You and your partner should have discussed that the median was 7. Okay, for class B, the median or the middle number would be 4. All right, so now let's move on to number 3. We're going to compare the two classes' usage of websites, including comments about the distribution of data and which class has more average use of web data. Okay, so now here we're going to look at our dot plots. Okay, so would you say that class A or class B has more sites visited? Okay, more web usage, excuse me. All right, so as you discuss with your partner or someone close to you, class A has more website usage, even though the usage is more widely dispersed than the usage in class B. Okay, so let's look at this again. I said class A has more website usage, okay, even though the usage is more widely spread out, because it ranges from 4 to 8, where here it ranges from 2 to 5, which is a shorter range. But in class A, they use it more than in class B. Okay, all right, so we're going to write that here. So class A's data is more, class A is more usage, okay? It is more widely dispersed. So class A has more website usage, even though the usage in B even though the usage, sorry about that, guys. The usage is more widely spread out than class B. Okay. Now, we just finished looking at dot plots. Now we're going to move over to these box plots. Okay. So here, I always tell you, look at what your the title of your graph, or if it tells you anything about your graph. So this is optical fiber diameters in milliliters, 30 samples per batch. Okay. So now we're going to use these box plots to answer exercises 4 through 7. So which batch of fibers has the smallest range of diameters among its samples? Okay, which one has the smallest range of diameters? Okay, I'm going to give you about 15-20 seconds to talk with your partner about which one would have the smallest range. Okay, so what I did here, I know my range is talking about how spread out my data is. So I'm looking at my whiskers. So if you look at your whiskers here for X, it's in between 0.3 and 0.4. So we know that it'd be 0.35. Okay. And the furthermost whisker is 1.3. Okay. Here for Y is 0.1 and 1.1. So we have to subtract those two. And then for Z, you have 0.2 and 1.2. So if you subtract all of these, okay, for X, you're going to get 0.95. If you do 1.3 minus 0.35. For this one, you're going to get 1. And here, you're going to get 1. So which one has the smallest range? It would be batch X. So we're going to say batch X. And we're going to say, because its range is 1.3 minus 0.35, which is going to equal 0.95. Okay, and we're going to say, give me a chance to write that. And in comparison to the other ranges are 1 each. The other ranges are 1 each. Okay. So now my next question is asking me, in which batches are the median and the upper quartile the same? So we know the median is the middle of the box. Upper quartile is the end of the box. So now I want you and your partner to figure out which one of these shows me the median and the upper quartile matches for those batches. Okay? Give you about 1 minute. Okay, so here what I did was I highlighted my medians. Okay, so we're trying to figure out which one has the median and the upper quartile that matches. So here's your median for X, and it matches Y's upper quartile. So the first one we're going to write is batch X and Y. Okay, that's one. Let's see if it's another one. Okay, for Y, there's its median. It matches with Z's upper quartile. Okay, and then we're going to say batch Y and Z. Okay. All right, on to the next question. Which batch of fibers has outliers? Take about 30 seconds and talk with your partner. Which batch of fibers has outliers? Okay, we know outlier is that it's all out there by itself. So which one of these box plots shows that there's an outlier? Okay, you and your partner should have come up with batch Z, because this outlier is farther from the upper quartile than the other. Okay, so we're going to say batch Z. Okay. All right. Now the last question says, in which batch are 75% of the samples no greater than 1 milliliter? Okay, take about 1 minute and talk with your partner. Okay, so you should have come up with batch Y. Okay, since 1 is the upper quartile, because it wants to know which batch are 75% of the samples no greater than 1. So its upper quartile is 1. Okay, below which 75% of its data are found in that batch there. So it would be batch Y. So we're going to say batch Y. And I'm going to say just what I said. Since 1 is the upper quartile, comma, below which 75% of the other values in that batch are found. Okay. All right. So we just did comparing populations. Okay. And we talked about the ranges, the maximums, the minimums, the outliers, interquartile ranges. Okay. And how to compare data with dot plots and box plots.